Okay. Hello again. Uh, our next speaker is Anshul. He comes from Baptist Health, South Florida, and he will talk about NLP use cases at Miami Cancer Institute. Baptist Health is the largest faith-based not-profit healthcare organization in the region, and Anshul is manager of Biostatistics and Predictive Analytics at Baptist Health from Florida. So, welcome, Anshul.
Thank you so much. Thank you so much for having me. And I hope everyone can see my slides. So today I will be presenting a natural language processing and application of machine learning methods on one of the projects that we recently did. And the detailed version is also published in one of the conferences. So I will also, at the end, leave the link or screenshot for that. And once again, my name is Anshul. I'm manager of Biostatistics and Predictive Analytics at Baptist Health South Florida in Miami, USA. So a brief overview of the presentation. So the project was in two parts. The first part was not so important in a way that the application or operational side of the first part, even though it was quite accurate, the final model, but the application was not so important. But the second part, where we were tasked to predict OP35 categories, which are basically 10 variables that are collected for quality of healthcare and outcomes. So we utilized natural language processing to process free text and applied some machine learning techniques. And I'll also present some of the results and the proof of concept. So, what was the first part of the project? So, in this part, we were asked to predict whether cancer patients who are coming to emergency department and also receiving chemotherapy in the past, whether their adverse events are due to the chemotherapy or is it entirely from something else. So, for example, a cancer patient who has received chemotherapy within 30 days comes to emergency department and reports that he or she is feeling dizzy or has a fever. Those symptoms could be because of the recent chemotherapy medication, or it could be due to, let's say, food poisoning, that patient ate something or took some other medication that had a similar outcome. So the attending physician or nurse or the medical personnel in the ED would enter the reason for visit or chief complaint in the EMR. So Baptist has Cerner as its EMR, and then the idea was to utilize that free text and kind of try to classify patients into two categories. That first, the adverse events are in fact because of the chemotherapy related medication, or adverse events are due to something else. And this is the first part, which is not really that important on operational side, because physicians or nurses who are entering this information in Cerner, they kind of know whether the symptoms are due to chemotherapy or not. But it is important that in case where the patient is not experiencing these symptoms because of chemotherapy, the oncologist who will come to examine the patient, basically the time of the patient while the patient is under observation, and the oncologist who is coming to see that patient, both time could be saved if there's a way utilizing machine learning or AI to classify that patient a priori and say like, hey, the probability of this patient's let's say adverse events being due to chemotherapy is very high, so this patient does require oncology consultation, or probability is too low, so we might discharge this patient home and this patient will not require oncology consultation. And once let's say a patient is classified that adverse events are due to chemotherapy, Hospitals are required to report those adverse events, such as fever, dizziness, even vomiting. So there are 10 variables for these adverse events that hospitals are required to basically create a registry and have data from all these emergency department visits of chemotherapy patients. So right now this process is manual. So someone, after it is established that these are chemotherapy related adverse events, a person would actually go in to the EMR and manually enter all this data after reading the chief complaint. So this is the main challenge that we wanted to focus on and automate this process using natural language processing. So for this project, we included all adult cancer patients who are on chemotherapy, and the index admission in ER was within 30 days of their admission. And how did we train this model? So once a physician has established that these adverse events are associated with chemo, they assign a ICD-10 code, which is a diagnosis code, T45. And using that, we created a binary variable, whether basically adverse event present or not. So that became our target variable. And again, benefit to patients is that unnecessary admissions or wait time can be avoided, and oncologists can also save unnecessary trips to ER, and unnecessary checkups also can be minimized. So basically reducing oncology consultations where it is not required. So on top is basically how the process happened before applying this NLP proof of concept. So cancer patient will come to ER as soon as someone will say, oh, this patient has a history of taking chemotherapy drugs. They would put that patient in observation and call an oncologist. So oncologists will then determine whether these adverse events or symptoms are due to chemotherapy. If yes, the patient will be admitted. And if it's not related to chemotherapy, that patient can be sent to, let's say, home or other ward, or cancer related medication, or a physician can be consulted. So what we are trying to achieve is the figure on the bottom, where cancer patient comes, and within ER, as soon as the reason for visit or chief complaint is typed in the field, with the backend access to Cerner, and utilizing text mining and predictive analytics, the patient is assigned a probability for adverse events related to, let's say, chemotherapy or systemic therapy. And if it's not, then patient can be classified as the reason for visit or chief complaint is not related to chemotherapy. And then oncologist call if the probability is high, and patient is either admitted or put on other medication. So what were the variables? So obviously patient ID was one of them, admit date, discharge date, prior discharge date, basically the ICD codes that we utilize to classify our target variable as a binary, and the free text from the chief complaint and reason for visit. And how does adverse event related to chemotherapy chief complaint looks like? So these are a few examples. So it can be very short and direct that, oh, patient has lower abdominal pain and a patient has history of lymphoma. And also somewhere in the past medical history or hospitalization, it would also be mentioned that patient is on chemo. And sometimes, as we can see, it's not as clear. They would write in great details, such as patient was watching TV at 4 o'clock and then experienced dizziness or funny feeling in her chest. And patient will also state like some past symptoms. So those symptoms can also come or can be written in this field, which is basically can create this more challenging to parse. So in the lower orange box, we can see that some patients have said that a patient denies fever and dysuria and chills. So that if we just using let's say a regular expression or simple word filtering, that will catch fever and chills as symptoms, but the denies word before the sentence is what will actually uh, be utilized to classify it further in any NLP algorithm. So next is some examples where the adverse events were not related to chemo. And as we can see, we do have some examples where it's very, very similar to chemotherapy related adverse events. And that's why, even though accuracy wise, this model was fine, but due to very similar words or some sentence structure, it is quite challenging to accurately predict the first part of this project. So patient can express like, hey, patient has history of colon cancer, but has abdominal pain. But here patient is not on chemo. So even though this is cancer patient, in ED, they might ask the patient to basically send back home with some other medication and not have an oncology consultation. But in some cases, for example, patient has fever and in chemo history too, they would enter that information as well. So it will be very, very close to the reason for visit or chief complaint will be very, very similar to uh, the other group, which is adverse events due to chemotherapy. So this is just operational workflow of data or how the algorithm will be trained and applied. So from ED, reason for visit were entered, and the data goes into our enterprise data warehouse. And through that, we pull the chief complaint data and the other variables as mentioned before, and run the NLP model and connect it with TabPy and Tableau, and just show a simple dashboard where patients can have like just probabilities or even a binary variable after a certain cutoff of probability to the healthcare provider. And this is basically how we operationalize the model. So the red box on the left hand side is the retrospective data that has reason for visit, and already the patient had ICD-10 code, so we were able to classify into a binary variable. The text was then pre-processed and again divided into training and test set. Model was built, and the model with highest accuracy was saved as a pickle file, which was then saved on the TabPy server. And whenever there is a new patient comes with a new reason for visit, same model would be run on the back end of the server, and the results would be shown on Tableau. So methods, as we all know, like NLP methods, and there are various libraries too, and various other tools to kind of annotate the free text. So for here, we mainly utilize NLTK and Spacey. And Spacey has a very decent text annotation tool. I believe it's called Prodigy. We had also tried Tucano. That was also fine. And apart from NLTK Spacey, there are Gensim, there's BERT. We can also try Hugging Face has several pre-trained model that if viewers want, they can also try those as well. So for the first part of binary classification, the best models were naive-based classifier and SVM, and the training and test set were just classically 70 and 30% split were made. And Out of 29,000 ED visits, we found out that around 2,000 or more than 2,700 cases were on chemo, and roughly 44% experienced adverse events due to chemotherapy. So, in ideal case scenario, we wanted to automate data collection from all these 1,200 patients for the OP35 categories. Prior to NLP and machine learning application, all these 1,200 cases would have been read by some healthcare personnel and manually entered in a database. So they would see like, okay, fever and pain words are present in the chief complaint. So they will just enter yes or no in the 10 variables that are required by CMS to be collected. And this is just a representation of how a simple chief complaint is broken down by pre-processing of text. So there's nothing too advanced here. And also the results for the naive Bayes classification and SVM are also on your screen. So they were decent in positive predictive value, precision, and recall values. But the main idea was to, again, get the OP35 categories. That was the main priority. So even if this model doesn't work well and a patient was classified manually as our, let's say, target candidate, then the free text from the reason for visit would be parsed to extract these 10 variables. So what are the challenges? As I have said, like if there are word or in a sentence, if it says like denies fever and cough, the model should not classify this patient as an adverse event related to chemotherapy. And the data should not be extracted for that patient if that patient has nothing to do with chemotherapy related adverse event. And similar case can be seen if someone writes not reported at the end of the sentence. So fever, cough is still there, shortness of breath is there, but it's not reported. So in the sentence, all these three words by just like simple filtering or regular expression, this would be very challenging to create like an expression to extract data. So natural language processing was relatively or comparatively easier. And the biggest challenge for the first part was that similar symptoms were also reported among those who did not have chemotherapy related adverse events. But the second part, which was, again, as you can see, was presented in the ASCO annual meeting. And this is where it really helped our physicians and nurses and reduce their manual data entry process. So OP35 categories are basically done, or data for OP35 categories are collected for hospital outpatient quality reporting purposes, and it's by CMS, and hospitals collect data on various measures of the quality of care. One of them is reporting of adverse events. And data from OP35 is later on used to assess the performance and the quality of care, and can be compared from different hospitals in that region. So patients, how they are treated at Baptist Health can be compared to X, Y, or Z other similar hospital healthcare systems in the South Florida region. And as I have mentioned, that this process is currently manual. So manually, they are going to collect information if chief complaint has anemia, nausea, dehydration, neutropenia, diarrhea, emesis, pneumonia, fever, sepsis, and pain mentioned anywhere in that free text. And let's say the patient has anemia and the patient complained of nausea and pain. In very simple database by patient ID and date, they will just enter yes, no, like 10 binary variables. So we treated this as a multi-label classification problem. So there are various tools and libraries in Python. We utilize skmultilearn for that, and SVC, then stochastic gradient descent, and other binary relevance methods were utilized. And the best performing model was by support vector classification, and with a Jaggard score of 85 and 90% accuracy. So it would still create some false positives and may miss some of the categories, but it would again reduce a lot of manual work. By after this, it would be just like reviewing the data which is already parsed from the free text. And as we refine our models, hopefully the accuracy will improve, and it will have fewer misses from the free text from the backend, because it's doing it in bulk. It's not like one by one. And as we can see, due to language and also how a person who's entering the data is reporting all these symptoms, can affect the actual outcome. So the future plan is patient comes in the ED and tells the reason for visit. So there are many things that can be done over their stay, and we are calling it like a trajectory from admission to discharge. So patient can come. Let me see if I can utilize a pointer. So ED and reason for visits are entered. So apart from reason for visit, a patient is not new and patient has a history of hospitalization. Patient might have various other variables like past medical history, some lab values, or other diagnosis, secondary diagnosis available. So apart from this free text, we can utilize other variables to classify patient into present or absence of our outcome variable or target variable that we are interested in. And at that point, prediction can be made regarding patient's discharge, whether that patient needs hospitalization or patient can be sent home. After a patient, if a patient is hospitalized, whether patient is going to get better and discharged home, or patient may go to ICU or post-acute facilities, or may even expire due to severity of the condition. And even within ICU, patient can be put on ventilator, or again can be back sent to the ward and home. So we can see, as long as patient is in the hospital, there are several opportunities to utilize machine learning and predict various stages of patient stay. But even when patient is discharged home, there is a chance that patient can be readmitted within 30 days. So 30-day readmission, in some cases 90-day readmissions after a procedure, are not considered good for the quality of care. So CMS will penalize hospitals if the 30-day readmission rates are very high. So during the stay and even after discharge, we can utilize various advanced machine learning and AI techniques to predict many outcomes, and try to create like a decision support system for our physicians and nurses. And thank you. And I'll take any questions if anyone is interested.
Thank you, Anshul, for the very insightful and great presentation. Let's see if we have any questions from the audience. Seems not. So yeah, thank you again for being us today. And yeah, that's it for the HealthTech track. We invite you to follow some other tracks, and see you a bit later.